All right, so continuing our discussion of projectile motion. So we've got questions 3 and 4 from the worksheet C03. If a monkey throws a coconut horizontally out of a palm tree that is 12.0 meters tall, and the coconut travels a horizontal distance of 15.0 meters, how fast was the coconut going when it left the monkey's hand? So let's first identify the pieces of information that we have. So it says that the tree is 12 meters tall. So that's our distance in the y direction. Distance in the y direction, 12.0 meters tall. And then it says that we have a horizontal distance of 15.0 meters. So that's our distance in the x direction. So what we need to do is figure out how fast the coconut was going when it left the monkey's hand. So that would be the velocity in the x direction. So we're looking for velocity in the x direction. That is our ultimate goal. Okay, to set that up though, we need to, in order to figure out what the velocity in the x direction is, we need to know the distance and the time. The distance in the x direction, which we were given, but we need to know the time. We can figure out the time spent in the air by that distance in the y direction. Because remember, its initial velocity in the y direction is going to be 0. If it throws the coconut horizontally, it immediately starts falling, but he wasn't aiming it down, so it doesn't have any initial velocity in the y direction. So, knowing that the distance in the y direction is 12.0 meters, we can just use our equation for a free-falling object, because the free-falling object is going to be the same as an object with an initial horizontal velocity. It's going to fall the same amount of time. So in order to figure that out, we take our distance in the y direction is equal to our initial velocity in the y direction, which is 0, okay? Because it's just, in the y direction, it's just basically the same as falling out of a tree, plus 1/2 times acceleration due to gravity, which is 9.8 meters per second squared, 9.8 times time squared. So time is what we're looking for, so if we plug in everything that we know, the distance was 12.0 meters, so 12.0 is equal to, well, the initial velocity times time. 0 is the initial velocity, so times time is 0, plus 1/2 times 9.8 is 4.9 times time squared. So then all I need to do is divide both sides by 4.9 and then take the square root. So if I take out my calculator, 12 divided by 4.9 is equal to about 2.45, and then I take the square root of that, and I get t is equal to 1.56 seconds. Notice that I didn't show every single step, but I divided both sides by 4.9. So divide both sides by 4.9, and then once I get that, then I take the square root of both sides, and that gets me to my t equals 1.56 seconds. Now I can take that and plug that in to my equation here. Okay, so the velocity is equal to distance in the x direction. The distance in the x direction was 15.0, so 15.0 meters divided by 1.56 seconds. And if I plug that in on the calculator, I am going to get approximately 9.62 meters per second. Notice 3 significant figures because both of my initial pieces of information had 3 significant figures. So that is the velocity that the monkey threw the coconut out of the tree. Okay, number 4, a bullet has a speed of 350 meters per second. Okay, so 350 meters per second as it leaves a rifle. If it is fired horizontally, okay, there's our key, so if it's fired horizontally, Okay, that means that we are going to have some sort of velocity in the x direction. Okay, so our velocity in the x direction was what it gave us, 350 meters per second. Okay, its velocity, its initial velocity in the y direction is 0 meters per second because it's being fired horizontally. Okay, it was fired from a cliff 6.4 meters above a lake. So the distance in the y direction, so up and down, is 6.4 meters. Okay, we want to know how far it goes when it hits the lake. So how far does it travel before it hits the lake? So that's what we are given right there. Okay, so again, this is going to be a two-step problem. We first need to determine how long it spends in the air, okay, and then we can determine how far it goes because, our velocity in the x direction is equal to distance divided by time. So the distance in the x direction is one of the things that we need to know, and then, or that's what we're looking for. The velocity in the x direction we were given at 350 meters per second. Time is what we are going to need to know in order to figure out what our distance in the x direction is. Okay? So again, we're going to set this up just like the one before in terms of figuring out what the free fall is from a height of 6.4 meters. So, our distance in the y direction is equal to our initial velocity in the y direction times time. Well, again, our initial velocity in the y direction is 0, so that's going to cancel out, plus 1/2 times a times t squared. A, of course, is our 9.8 meters per second squared for gravity, and our distance in the y direction is 6.4 meters because that was given to us. Okay, so if I plug everything in, 6.4 meters equals 0, that goes away, 1/2 times 9.8 times t squared, 4.9, 1/2 times 9.8 is 4.9, equals 6.4 times t squared. Divide both sides by 4.9, t squared, and let's go ahead and do that on the calculator. So 6.4 divided by 4.9 is approximately 1.306, and then I need to take the square root of both sides to get t is equal to 1.1. So 1.1 seconds, so approximately 1.1 seconds. Okay, I then plug that in to this equation. 350 meters per second is equal to the distance in the x direction divided by 1.1 seconds, the time that it spends. Okay, so that's meters per second. So I just multiply both sides by 1.1. Okay, and so I do that, and I get approximately, so 350 times 1.1 gives me about 385 meters.